All right, guys, it's time. I'm going to officially start this meeting. My name is Gergana Petrova. I work at RIPE NCC. For the past several years at RIPE meetings, we've been organizing a special session for academics and for NRENs with the purpose to showcase their work. So I just want to start with a few logistical issues. First, I want to tell you that we're recording this session. I don't know yet in what format we're going to make it available online, but at least it's going to be available on the RIPE 80 website. Today we expect 8 presentations. It sounds like a lot for the 1 hour we have, but we've scheduled each of the presentations for 5 minutes. The idea is that the presenters are going to give you a very quick overview of their research, what they're working on, and then you can follow up with more questions after the presentation, or they can also write in more detail if they choose to, for example, on RIPE Labs or another platform like that. So the 5 minutes is really just to give you a quick idea on the work that they're doing. And I'll be really strict with the timekeeping. At the 4th minute, I will indicate to the presenter 4 minutes, and at the 5th minute, 5 minutes, so that you know that you have to wrap up. If you have seen the program online, I'm going to give the floor to our first presenter, Yulia Krivonosova from Taltech University in Estonia. So Yulia, take it away.
So shall I introduce first myself or with, okay. Yeah, so I'm from Tallinn University of Technology. I'm working in the research group together with Professor Kramer and Dr. Diana Sid, and we study elections from a social science perspective. So we mainly focusing on internet voting, and we trace how governments implement it. So we focus not on the technology per se, but we try to cover more broader organizational perspective. So I guess I'll be the less technical speaker today, but I'll still try to keep it entertaining.
All right, thank you. I think you can, if you click on the share screen, you can.
Okay, so we start directly with the presentation.
Yeah.
Got it.
Yeah.
Sorry.
No.
Yeah.
Hello, everybody, by the way.
Yeah, someone said hello.
Yeah.
So I'm ready to start. This is a story about the government which promised its citizens to deliver elections to those citizens living abroad. So they said they would be able to vote on the internet, to learn a few days before the election day that internet voting was cancelled. It happened in the Åland Islands, which is a Swedish-speaking autonomous region of Finland, and it's an archipelago with thousands of islands. In 2015, 15 since the start of the debate about internet voting, Åland Islands decided to introduce internet voting for 2019 elections. However, in October 2019, a few days before the election day, they took a decision to cancel it. Our research team conducted 2 visits to the Åland Islands in June, when the implementation of internet voting was still in full force, and in October, shortly after they took the decision to cancel internet voting. So the main questions we wanted to know was why they decided to introduce internet voting and how they tried to use it, to implement it, and then why they decided to cancel it and how they still happen to deliver elections without it. I'll skip the theoretical framework and methodology for the time's sake, but I'll be happy to answer in the Q&A. So what did we find? I'll present only a few major findings for each research question, but for the full findings, I'll refer you to our paper, which we promise to publish soon. So the first research question was, why internet voting? The alternative voting channels for voters living abroad, postal voting, which they used for 30 years, apparently had some problems. On average, every elections, 10% of ballots get lost. Then, among the reasons, there were reasons related to the self-governance and smallness, and also some aspirations for regional leadership. If you're interested to learn more about the motivation to introduce internet voting, we published a preprint, and I believe if you click on this slide, you might be sent to the paper. Otherwise, there is also a website in the lower part of the slide. The next research question was how to implement internet voting. We found that much more actors were involved in delivery of internet voting in comparison to paper voting. Many of those actors were private actors, and some of them were also from abroad. Then there was a striking difference between the time spent on planning internet voting and time spent on the actual development of the system, with the latter being much shorter. The next research question was why to cancel. On the day when internet voting planned to be started, the government took the decision not to start it. Reasons? From the government side, the system was delivered with delays, partially due to multiple errors and quality problems with the software. In the end, when the system was finally delivered, the government didn't have time to properly check the system by the independent body. So they decided to cut elections. What this cancellation resulted in? Potentially all the voters living abroad got disenfranchised because they needed either to urgently ask for a ballot to be sent to them by mail, receive it and send it back, or to travel back to the Åland Islands. For many of them, both of those options were not possible anymore because of the shortage of time. Still, some voters managed to cast a ballot. Conclusions. What is so special about the Åland Islands? Well, the previous research on internet voting focuses on how voters could get affected during the process of voting or after it, because the technology is compromised and, let's say, voter choice is leaked. This case, the Åland's case, represents a new scenario showing how voters can get disenfranchised even before they get to vote, just because the solution, the system, is not delivered. And the government of the Åland Islands, as we found out, were not ready for such a scenario. That being said, the main lesson we draw from the Åland's case is whatever good intentions the government could have while implementing internet voting, either increasing voter convenience or enfranchising new groups of voters, the problems with implementation may result in quite the opposite, even greater disenfranchisement and lesser convenience. Thank you for your attention, and I'll be happy to tell you more about it in the Q&A session.
Thank you very much, Julia. If you have any questions, please either ask them in the group chat and then I can read them out, or you can raise your hand and I can give you the floor to speak. Actually, you just unmute yourself. Really interesting presentation, Julia. I was wondering, did people say why they decided to cancel it? What was their concern? Was it that they couldn't? I suppose software like that needs to be able to identify each citizen, not allow them to vote more than once, or did they have security concerns? Did they say?
Yeah, there were multiple problems with the way the system was developed, but the final decision was taken on the ground that the system is developed by the private actor, which is kind of frequent in the field of internet voting. Governments usually do not have expertise to develop these systems themselves, especially small governments like the Åland Islands. Still, due to the relationship between the government and vendor, government decided that they couldn't just blindly try and the vendor actually fixed the problems. So they tried to ask the independent body to check the system, but all independent bodies with whom they worked said that it's impossible in this time span. So they took the difficult decision not to start it.
Right.
Thank you.
Makes sense. Thank you so much for your presentation. I'm going to move to the second one. However, if there are some questions by the end of the session and we still have time left, I'm going to come back to you. Thank you again. So who I have next? Nico. Nico, I found your last name a bit hard to pronounce. Schotelaus?
You are not the only one. Not the only
one. What's the correct way?
So it's Nico Schotelius.
Oh, Fantastic. Well, take it away and give you the floor.
Thanks a lot. Thanks for having me. First place, as I said, my name is Nico Schotelius. I'm talking a bit about high-speed NAT64 today, which I focused on my master thesis at the end of 2019. And before I go into detail, I will probably just have a very short overview of like what NAT64 is. I don't know how familiar you are with it, and also what the current state is. So I did this within my master thesis, but aside studying, I also run a company named Ungleich, even also very easy to pronounce, which is focused on IPv6 only hosting here in Switzerland. So it's a big data center with primarily IPv6 only resources. The challenge that you have there, and the challenge that you have in general at the moment, is when you transit away from IPv4, you can go to dual stack networks, or you can go to IPv6 only networks. And when you go to IPv6 only networks, which is in a way the easier way, you at some point need to translate access to the IPv4 network. So you have resources that are IPv6 only, but they can still reach the old IPv4 internet. A common service used for this is NAT64, which basically translates IPv6 packets into a special network, an IPv6 network that whole IPv4 internet. So if you have a lot of resources in this regard, the problem at some point is, or your translator, your NAT64 translator, actually can become bottleneck of the whole IPv6 data center. And that's obviously nothing you want to have or you want to be locked into. So the topic of my thesis was to explore a bit, like, how does it look like in software? How does it look like in hardware? And there's a very interesting programming language. Some of you might have already heard about it. It's called P4. And P4 is a programming language intended to be for switches or network equipment. So you're able to program at line speed. So whatever you have, be it like a 1 gig, a 10 gig, 100 gig, or even higher, your code in theory runs at the same speed. So if you have a higher speed equipment, by P4, it's still guaranteed to run even at the highest speed your hardware basically supports. P4 itself is adopted by a variety of vendors, like from Arista to Barefoot to whatnot. You can get them the variety of vendors. What I used for my thesis was, first, there's a software emulation called a BMV, behavior model, to actually mimic what a hardware switch would be doing. In the end, I used a NetFPGA networking FPGA to actually implement it in hardware. So what is quite interesting there, because I'm talking mainly in the scope of IPv6, is that hardware in general doesn't like variable length things. So if you have a packet that's always like 80 bytes long, that's great. If you have a packet that's like sometimes 80 bytes, sometimes 82 bytes, these are things that are really tricky for reading on the network, because you have to imagine you're processing things at 1, 10, or 100 gigabit. So you don't have a lot of time to do things, but you need to kind of look at it before. So IPv6 in this regard faces some problems, because you have things that are variable length, which you can't actually process at line speed because you don't have the time to look for a lot of headers. You can do for a limited amount, but you might not be able to do it for everything. Luckily, in this case, like translating from IPv6 to IPv4 and vice versa only requires a certain amount of fields to look at. So this actually can be done in hardware. And today, I would like to talk a lot about the challenges that are in there. I will skip this for today due to the time. It is quite interesting, and also to be able to see like what kind of design challenges are actually brought up by IPv6 there. In the end, which is quite interesting, I compared two software solutions. One of them is named Taiga, which is a Linux open source implementation. and YOL, which is a Linux kernel module, and the net FPGA, the hardware card itself.
1 minute.
Thanks. So the original software solution, which runs as a regular program on any computer, maxes out at a current CPU around 2 to 3 gigabit per second. Then you're basically CPU bound. The Linux kernel is actually quite surprisingly fast. It runs around 8 gigabits per second on the same hardware, just a little bit different code. And the net FPGA itself, and that is a really nice takeaway, it actually was able to sustain line speed at around 9.2 gigabit per second. So the result is, in the end, with P4, you can realize NAT64 translations in hardware at line speed. And potentially what I have done, the code, I 10 gigabit per second, but you could use the same code for running at 100 gigabit or terabit or even more. That's it in a nutshell. Very short and concise.
Thank you very much, Nico. Do you guys have any questions? You can either raise your hand or please post it in the chat. Let me see if somebody's raising a hand. I see Hisham commenting, we need more people that can do FPGA in our community.
It's quite a painful job, I can assure.
All right, well, thank you for the talk, Nico.
Thank you.
I'm going to move to the next one. In the meantime, I see that Julia has shared her email address and Twitter handle in case you want to get in touch with her. So I'm going to move to the third presentation from Baha Al-Musawi. He sent me a recording in case the connectivity is bad, so I'm going to try to share it now. Please bear with me.
Hi everyone, this is Baha Al-Musawi. Today I'm going to talk about rapid detection of BGP anomalies. The outline of my talk as follows: a brief discussion about BGP anomalies, our novel technique to detect BGP anomalies, how we developed our technique to real-time BGP anomaly detection tool, or RBAT. Then I will conclude my talk. Detecting BGP anomalies is a much harder problem than it seems at a first glance, where BGP traffic has been identified as a complex and noisy. Recent statistics shows that 20% of BGP anomaly lasted less than 10 minutes, but able to pollute 90% of the internet in less than 2 minutes. Consequently, there is a need for real-time BGP anomaly detection without requiring a long history of BGP traffic. The consequences of BGP anomalies can range from a single to thousands of anomalous BGP updates. A single BGP update is categorized as anomalous update if it contains an invalid AS number, invalid or received IP prefix announced by an illegitimate AS. While a set of BGP updates are classified as an anomaly if it shows a rapid change in the number of BGP updates containing longest and shortest path, changes in the behavior of total BGP traffic over time. Our interest is in the latter, in particular, how to find out BGP anomalies using a series of BGP updates rather than looking into individual information in each update. To find out an appropriate technique that can differentiate between normal and anomalous traffic, we model BGP speaker as a dynamical system, where a BGP speaker is a router or device that runs BGP. The outcome of our modeling shows that BGP speaker has the characteristics of being determinism, stable, nonlinear, and recurrent system. Based on this outcome, we use recurrence quantification analysis, or RQA. RQA is an advanced nonlinear statistical analysis technique based on the concept of factors. RQA is a stable technique that has been successful to model dynamic behavior of such system found in physiology and mechanical engineering. RQA has multiple measurements which are called RQA measurement. For example, recurrence rate, or RR, that represent the probability that a system will recur after a number of time states. Our scheme is comprised of 4 stages, as shown in figure 1. We use 2 BGP features, each BGP volume and average AS path. We use the moving average technique to smooth the values of RQA measurement to enable detection of changes. The decision stage represents the logical OR of multiple RQI alarms. Evaluate the ability of our RQI scheme to detect BGB anomalies. We use BGB data related to different types of BGB anomalies. For example, NIMDA is an example of DOS. Moscow is an example of hardware failure. TTNet and TMNet are examples of misconfiguration by BGB operators. Figure 2 represents the output of our RQI scheme to detect BGB anomalies using BGB traffic associated with TTNet event, where we can see there are 6 alarms arising from our RQI scheme. RQI is not restricted to detect high volume of BGB traffic. It can detect some hidden anomalies that have not been observed before. For example, RQI raised an alarm where the pure autonomous system stops sending any BGB update for 2 minutes. Figure 4 shows an example of early detection of BGB anomalies, where RQI detected anomalies before 730 seconds of sending a high volume of BGB traffic. In total, we ran our RQI scheme for around 2 weeks of BGB traffic collected from different types of prolonged BGB events. The evaluation of our RQI scheme has a F-score value of 91% and a precision value of 83.6%. RQI requires only 3 minutes of fast BGB traffic to detect anomaly in a range of 1 to 200 seconds. We developed our RQI scheme to real-time BGB anomaly detection tool, or RTBAT-T. RTBAT-T provides real-time plot, log timestamp of BGB anomaly with their BGB traffic for further investigation, and finally, ever sending of an email notification. To evaluate our RTBAT-T2, we use the simple topology shown in figure to replay BGB traffic related to BGB event using BGB replay tool, or BRT, a tool that we developed to replay past BGB traffic timestamp. RTBAT-T raised 8 alarms when replaying BGB traffic related to TMNet events. In addition to its ability to detect high volume of BGB traffic, RTBAT-T also raised an alarm when BGB speakers stopped sending BGB traffic. Conclusion: detecting BGB anomalies is a challenge. RQI requires 20 minutes of fast BGB traffic to detect anomalies in a range of 1 to 200 seconds. RQI can detect hidden abnormal behaviors that may pass without observation. RQI can detect BGB anomalies with 99% accuracy and 91% of F-score. Our next step is to deploy RTBAT-T to a realistic scenario. Some useful links and sources that we use in our project.
All right, thank you very much, Baha. I will upload all the slides on the agenda hyperlink in case you want to look up the references that were shown last. In the meantime, do you have any questions for the presentation?
I was wondering if there's any integration with typical routing software like BERT or FRR already to actually block the routes or the origins then.
Thank you, Nico, for the question. Actually, no. The development of the tool was based on using some software in Perl. So we developed some libraries so we can collect the real time of BGP traffic, and this library can provide some BGP features such as BGP volume and ASPAT. So currently I'm not using BERT or Quagga, so it's based on some library from Perl.
Baha, just one more question from Hisham on the chat. Have you come up with a set of recommendations for operators to address the issue, or do you just detect them for now?
In my topic, in my project, I'm calling some internet service provider operator to deploy my tool. So currently I'm using testbed to evaluate my tool, but my next step is to deploy it within real internet service provider. The RTBAT, it's a little different from BGP stream. If someone have heard about BGP stream, so the difference is RTBAT can detect anomalies at AS level. It's not like deploy it for all the internet. So detecting anomalies at AS level can reduce or increase the stability and reliability of the BGP routing.
All right, thank you. One more question from Chris Cousins. has there been any comparison to BMP, and also how would it be impacted if RPKI was implemented?
Yeah, honestly, I have accepted paper recently from Australian journal, and there's some comparison with other technique that has been used before. I can share the paper after published because it's currently just accepted. Furthermore, my thesis, which explain and describe all the technique for RQA, how do we evaluate, and all the tested and the analysis is available online.
All right, thank you very much.
I can share it with you. Yep.
I can make it available on the agenda link. Thank you very much. Just to recognize, I have a question for Nico pending from Gordon. If that is okay with you, I'm going to gather all these questions that people came in with in the meantime, and I'm going to hold them until we're done with all the presentations, and then we can have questions towards all the presenters, if that's okay with you. So thank you, Baha, very much for the presentation. I'm going to move to the next one, Thomas Schäfer. Thomas?
Yes.
You're around? All right, take it away.
Yes, my name is Thomas Schäfer. I'm working for the Ludwig-Maximilians University in Munich, Germany. And I want to talk a little bit about my IPv6 experience I have since 2005, the time when Join and Sixbone went down and we started at productivity. I'm working for a small unit called CIS, Center for Information and Language Processing. And we have some servers, some workstations, and also some mobile devices. It's part of a Munich scientific network owned by the Leibniz Supercomputer Center. It's a great campus together with other universities. I use mainly Linux, OpenSUSE, Ubuntu, and some virtual machines. We also have macOS, Windows, and yes, and here you see some restrictions. I still have some IPv4 only devices. And I have also some IPv6 only devices, for instance, file servers, network file system, ZIPs, the backup software by IBM, and network time protocol runs only over v6. Okay, I started with 2005. This is a comparison of 2010 and 2020. As you see, IPv4 is still the most, but the part of IPv6 is increasing. Now we are in the same range and not some tenths less. Yes, that's my magical triangle: university, home, and mobile, and that's the time 2006. IPv4 only, a lot of net, and 2010 something have already changed. I used a lot of 6 tunnels and EtherTab, also a tunnel, and yeah, it was progress, but it's not good. 2020, everything is IPv6 native. The university has dual stack. I have at home IPv6 and on the way to. What do I mean? I provide a lot of services via IPv6 and of course via IPv4. Email, web services, subversion, also source code management, remote software. Also internally, everything is at least dual stack, and some things already, I said, is IPv6 only, like the network file system. Of course, I have to filter something. I use IP6 tables for that. So what happened outside the university? The first time I used a 6 tunnel. When I was switched to dual stack by the telecom, And later on, 2 years ago, I moved to a regional ISP with DS Lite, and it was the first step to say goodbye IPv4, because, or since it's just carrier grade NAT. But at the, I have more speed, and I have a very native and reliable IPv6 access now. No tunnel anymore. For mobile, I started with 6 tunnels too. And then I got an early access to a test by Vodafone.
1 minute.
Okay. Yeah, and I made some things in the development of Modem Manager a little bit. Same timeline for telecom. Now here from IPv4 only to IPv6 only, with NAT64 as already mentioned by Nico. Of course, sticks are not the world. Most people use smartphones, no problem. Also, it works well. Special use cases are VPNs from and to the university. To the university, we use Cisco. There is IPv6 and IPv4 inside and out the tunnel. In the other way, I use OpenVPN of the tunnel. The transport protocol is IPv6 only, and inside the tunnel, the payload is dual stack. Besides some personal services like VPN and my storage, NAS and remote desktop, I use also commercial applications for smart home. Here you see my temperatures from some day ago. And last but not least, I installed a Jitsi instance caused by Corona, of course, and it works with IPv6 too, peer-to-peer. Yes, that's in short of my IPv6 experience for last years. Enjoy IPv6. It's the internet. Thank you.
Thank you very much, Thomas. Do you guys have any questions for Thomas? I'm just trying to monitor the participants list for any raised hands, but you guys are so many. If not, I'm going to come back. If you have any questions, I'm going to come back to the presentation later. Thank you, Thomas. I'm going to move on to the 5th presentation for today, Rutger Birkner. Rutger, do you hear us?
Yes.
All right. Yes. I give you the floor.
Good, thank you. Yes, so my name is Rutger Birkner. I'm a PhD student in the Network Systems Group at ETH Zurich, which is led by Laurent van Bever. And what I'm going to talk about today is basically how we, in one project, aim to facilitate intent-based networking. And intent-based networking, okay, like this. So intent-based networking is kind of a buzzword that has been around for quite some years, and all of the major vendors have somehow some intent-based initiatives, more or less. And what they all have in common that you need to have, or that you need to know your intent. And one kind of application of intent-based networking are network verifiers. So there are quite a few tools that are commercially available, and they allow you to check that your network actually behaves as you intended, such that your network implements your intent. They all follow the same recipe. So you upload your configurations, then you define a specification. That's just a formal term for your intent. You run the tool, and based on the results, you either change something in the configuration or deploy it directly. Now, the big question is, what is actually this specification? What is this intent? So to begin with, let's quickly look at the definition. So a specification of a network kind of consists of two parts. First of all, you tell your network, or in the specification, you say how your network should behave. So what needs to hold in your network? It's basically a list of policies. And you tell the you tell when these policies need to hold. So under what circumstances does this behavior need to hold? And here we just have a few different link states. So when some links can fail and your policies still need to hold. So this definition is actually quite simple, but writing the specification is not that simple. Just imagine a larger network. It has grown organically over multiple years. Multiple people have worked on it. Some have retired, some have left the company. So it's actually quite hard to get an overview of what your entire network actually does and write this down formally. And this is not just a problem in networking in general, but it's a problem anywhere where you need to write down a specification. And actually, we talked to one network operator that told us that they wanted to deploy a tool that automatically consistently verifies their network. And in the end, they did not use the tool because they did not manage to write down the full specification. It's also what the recent paper from Hotnets claims, that basically, apart from the large network operators or cloud operators, not many networks use those network verification tools. And one of the issues is, or that's what we claim, is that it's hard to write down the specification. And that's where actually we come into play. So a group of researchers from ETH, we have created a tool. It's called config to spec, and it automatically mines your network's configuration. So config to spec takes as input your network's configuration and your failure model, and it will automatically find all the policies that hold for this configuration and failure model. And for this, we kind of rely on two parts, on data plane analysis and control plane verification. At the high level, I will quickly explain you how this works. So it's basically consists of two phases. First, we try to narrow down a guess of the specification. And in the second phase, we try to validate this guess. So first, we start with the failure model, and we start with an initial guess that contains everything. And then from the failure model, we randomly pick some concrete environment, run it through data plane analysis, which will then tell us which policies actually hold for this one specific environment. And we can repeat this more and more, and like this, we can slowly narrow down the guess, so the policies that actually hold for all environments. At some point, we will kind of reach a local minimum, and that's the point where we switch to the second phase, where we take this guess, and one by one, we take every policy in this guess, run it through a verifier to validate whether this policy holds, like here, or whether the policy doesn't hold and is therefore not part of the specification. So we do this for all those policies in the final guess, and we'll end up with the specification. And also thanks to this two-phase approach, we kind of first make sure that we don't exclude any policy that is part of the specification. And in the second phase, when we validate it, we make sure we don't include any policy that is not part of the specification. And that was already it. So this is a very, very high level explanation of how it works, so of how we automatically learn the specification. If you want to know more and are interested in it, please check out our paper from NSDIA this year. We're still working on config to spec. So on the first hand, we will always want to extend the policies and the specification that we actually support. And we also think that we can use this semantic understanding that we get of the network to automatically detect some network misconfigurations. So please, if you're interested in this, if you have any inputs, feedback, questions, reach out to us and visit our website of the Network Systems Group. And that's it. Thank you very much.
Thank you very much, Rutger. Any questions for Rutger? Do you guys have? Please raise your hand. Gordon is asking, it's not quite clear to me whether config to spec mines the specifications of the network from the data plane data, for example, LLDP, or the actual equipment configuration.
So it's actually the equipment configuration. So we take the configuration, but then we use tools, a tool called Batfish to simulate the network configuration, to kind of compute the data plane state from the configuration. But as input, we really take your Cisco or Juniper configuration.
All right, thank you. Any other questions for Rutger? Baha, I see you've raised your hand. Please go ahead.
Yep. Yeah, thank you very much for your interesting presentation. I have just one question. Have you checked your tool or your technique to with different protocols, such as routing protocol, for example, or just limited or restricted to network configuration? In other words, yep, sorry.
No, just because I'm not sure I fully heard. So you asked about the routing protocols, right?
Exactly.
Yes. So we tried it for OSPF and BGP, so IBGP and eBGP configurations.
Good. Interesting. Because if you can succeed with that, that will be really interesting. There are many problems with BGP configuration, and there are 10 or maybe hundreds of BGP misconfiguration happen per month, per year. So it will be interesting to see that.
Yes. So this is our next step, because I don't want to take too much time, but basically we say at the moment we learn the specification, but what do you do with the specification? And one part is to detect anomalies in the specification, which then would mean you had mistakes in your configuration, so misconfigurations. But we can also talk about this offline.
Okay.
All right. Thank you, Rutger. I'm going to move to our sixth presentation, Andreas Siskos. Andreas, do you hear us?
Yes, can you hear me?
Take it away.
Okay, thank you. My name is Spiridon Andreas Siskos. I'm an undergraduate student at the University of Crete, and I'm a member of Inspire group at 4th ICS. And today I'm going to present you our work with Petros Gigis, Lefteris Manasakis, and Xenophontos Mitropoulos. Oh, I forgot to share my screen, right? Yep. So now you can see also my screen. Okay, let's start again. My name is Spiridon Andreas Siskos. I'm an undergraduate student at the University of Crete, and a member at the Inspire group at 4th ACS. And today I'm going to present you the work that I'm currently working on with Petros Gigis, Lefteris Manasakis, and Xenophontos Mitropoulos, which is called Smart Data Filtering in the RIPE Atlas Measurement Platform. First, some background. So, researchers and network operators use data plane measurements for network monitoring and diagnostics. RIPE Atlas is an inter-measurement platform that allows users to make their own campaigns and access those data through a REST API. But this API lacks more advanced filtering, which would help users to take advantage of those data more efficiently. So, in this work, we tried to enable advanced filtering over RIPE Atlas API, explore RIPE Atlas collected data more efficiently, use filtering over traceroute data, and provide an open source framework. So our prototype framework, we used to build it Python 3, Django Web Framework, a relational Postgres SQL database, and we run it as a multi-container Docker application. So first, we started with downloaded and crawled metadata from RIPE Atlas. Then we analyzed those data and enriched them. And then we insert them into our database. And this is our indexed metadata. As you can see, we used IP addresses, end source and destination, also ASNs and date times. But how can a user take advantage of our API? Step one, the user queries to our API. The API returns to the user a set of URLs pointing to the RIPE Atlas, and then the user retrieves the results based on his initial query. But to make it more clear, let's use an example. Let's say that the user wants to fetch all trace routes from Vodafone towards Facebook. First, the user issues an advanced query to our API. In our example, he sends an HTTP GET request with parameters source ASN to be the ASN of Vodafone and the destination ASN to be the ASN of Facebook. Then the API returns a set of URLs to the user pointing to the RIPE atlas, and the user can retrieve his results from RIPE atlas based on his initial query. So our conclusion is that we built an open source prototype for filtering RIPE atlas data, and the preliminary results show that it can significantly accelerate advanced queries. And for future work, we would like to extend the framework API functionality, for example, to support all measurement types such as HTTP, DNS, etc. Also improve its performance and scalability, and make it work in real time by fetching data automatically from RIPE atlas. So that was my presentation, and I want to hear some questions for you. Thank you.
Thank you, Andreas. Any questions? Let me look at the participant panel. Please raise your hand if you have any questions or type your question in the chat. Dimitrios Maruli, I cannot finish the last name. Where can
it's Marulit. Yeah, it's a Greek name, actually.
Where can we find more info about the API?
Yeah. It's now it's code is not available yet, but it would be released soon. You can send me also an email or me or Petros to give you more information about that.
All right, thank you. Natalie is asking what's the added delay time?
We saw that that there are about a few seconds for our API to give back the results, so they're very good. There are a few seconds, like 2 or 3 seconds for the hardest one.
All right, thank you. Any more questions? Let me just quickly see the participants panel. I don't see any raised hands. Well, thank you very much, Andreas.
Thank you.
Just for you all to know, I will upload all the slides in the agenda so that you can check all the links, the emails there as well, and the references. So I'm going to move to Vladislav Bidikov. Do you hear me?
Yeah, here, just starting to share screen.
All right, go ahead.
So, good evening, everyone. I'm Vladislav Bidikov from the Faculty of Computer Science Engineering, and I'm going to show you a small 25-slide presentation in 3 minutes on how did we manage to shift and how we changed from out online because of COVID-19. So first, the problem description. Let me just try to remove the video. Okay, the problem description is the Faculty of Computer Science has around 4,000 active students, and due to the COVID-19 pandemic, we were ordered to close on the 11th of March 2020. The big challenge was how do you organize classes for our students and have up to 10 parallel sessions on the faculty service. But also we saw this as an opportunity because we already had the chance to use our existing faculty infrastructure and network capability. We accepted this challenge and we tried to continue the lectures fully online. What were the main implementation challenges? Of course, the first problem was infrastructure, CPU, RAM, and storage. Second was having good internet capacity. The third part was provide excellent end user experience in audio and video, both for our students and professors. And the most interesting part, my favorite, do everything in a very, very short period of time. What we actually did, we already had our own infrastructure ready for this based on the existing resources of the faculty. So we just improved the capability and reachability of our infrastructure to be fully redundant and to expand everything in order to fulfill the need in storage and networking. You can see the diagram here. So 6 big Huawei servers, a big storage system, and redundant switches both on the fiber channel and Ethernet side. Then the interesting problem, how do you maintain connectivity in a situation like this? In order to provide better user experience for our users, we already just expanded what we had in the topic of networking. We are well connected to the internet based on 2 internet uplinks. One is our 1 gigabit upstream via the NREN project, which is provided by the university network. And we have a 500 megabit upstream to a commercial ISP thanks to the Ministry of Education. But the most important part in this was that we actually run a university faculty project for an IXP called IXP.mk, which is now 2 years old, to which we are actually connected to 10 gigabits. You can see here the current state of connected peers at the IXP.mk. Just to let you know that before COVID-19, the number here was only 3 operators, and you can also see that actually we had all the major ISPs are here, including Macedonian Telecom, who saw the problem and the opportunity, and they decided to join the IXP in just 2 days because they already had the fiber lines lying around. The software implementation, what we did was what we already had based on our Moodle learning management system, but we also had to scale a bit in order to be able to work. So the a 2-part system was designed. The first was the course learning platform, which had 3 nodes in the cluster. Then we had a separate course exam platform based on Moodle, which had 4 nodes. And the database server was shared between the platforms. And for the video conference part, we used Big Blue Button as a web conference platform, for which we actually created an 8 cluster node and a special load balancing machine, which we had to design based on the specification of the Big Blue Button. And of course, had so each of the uplink and the network capacity to be around 10 gig. We did this in just 3 days actually, and we started to test with the system. And this is how it looks. Here you can see how we actually still do our classes every day. We saw that traffic depends mainly on the classes and the number of students in some classes. This is really notable in the first year when you have a large number of students, around 1,000 going to one class, and here you actually have to split them separately. And most of our infrastructure was working quite well. You can see that we have some very popular classes. You can see the 5th node on the bottom screen, which actually by itself generates around 150 megabits for 2 times when there is a class. And at the beginning, the aggregate traffic, we finally saw some real traffic in the IXP framework with traffic running records around 300 megabits, which for us as a small IXP is really a lot. We did a survey just to see what they think, and you can see the results. Online versus traditional classes between student and teachers, you can see that online is much better or equal for most of our students, and for the teachers equally good is generally the main story. We still have to do a lot because we are still in the COVID-19 situation. We actually do this from the 17th of March, running systems online completely. We are generally satisfied with the results. We saw that older students prefer online lectures rather than traditional ones, but we still need to do surveys, and we are targeting a June exam week, probably, if we don't lose, if there is no removal of the curve, also will be done online. If you have any questions or details, I'm available for you.
Thank you, Vladislav. Any questions? Please write it in the chat if you want to ask something, or raise your hand in the participants panel. Randy is asking how many is admins?
3, only 3, Randy. Myself, my colleague, and one more, a youngster, like he's 22. So only 3 people are actually running this.
All right.
Yeah, Hish. Those SFPs are actually the reason why we can connect fiber in 20 minutes.
All right, any other questions? Gordon is asking, what other solutions did you explore for remote conferencing?
Okay, I can answer this in 30 seconds. Before we tried the big blue button, we first tried the commercial ones, and we had problems because our geo connectivity issue is a big one. And we tried Microsoft Teams, Zoom, and everything else, but we were most capable of big blue button because actually it uses a platform or components which some of us really know and know how to improve, and we were able to tune the load balancer to do its job, and also because it was easy for us to scale up the system on the concept we have designed. Because we control the number of nodes on big blue button, we can easily add hundreds of nodes as new VMs, and traffic is still just local, and this is the main benefit, because all other tools will probably go over Frankfurt or Vienna or maybe in Sofia. So latency is terrible, and what we saw actually, and why operators joined probably the exchange, was that because of people working from home, the internet provider capacity was just well overwhelmed. So they were running around 90–95% on capacity all the time. So all the other platforms just didn't work.
All right. Thank you very much for the presentation, Vladislav. I'm going to move to our last presentation for this session. David House here. Do you hear us?
Yes, I can hear you. I hope you can hear me as well.
Yes, we can
okay.
hear you. Right.
Thank you very much for the opportunity to give a presentation here. That's very appreciated. I also share the slides in PDF in the chat, and my email address if you have any questions or comments. Just let me go to full screen here. I hope that's going to work. All right. I hope you can see my slides now. So my name is David Hauser. I'm a university professor at the University of Magdeburg in Saxony-Anhalt, Germany. This is joint work together with Adrian Perrick at ETH Zurich. And the topic that I would like to share with you is secure networks for IoT devices. So Internet of Things, or short IoT, as I guess most of you know, refers to network of smart objects, which are mainly used to collect and analyze data. This has use cases in many areas, including smart home, assistance for elderly people, but also healthcare and critical infrastructures like transportation or manufacturing. The characteristics of these networks are that they are typically composed of small-scale devices that are equipped mostly with sensors, but they are usually low-cost devices that have a low energy usage. Now, Bain predicts that the IoT market may grow to about $520 billion by the next year, which is more than double than it was in 2017. Now, one of the interesting aspects is that security of Internet of Things is being seen as a big concern in adopting IoT technology, especially in enterprises. Some of the threats that are being seen as an issue in terms of security of IoT are the fact that those devices can fail or be attacked, which of course hinders the adoption in critical infrastructure that usually have high availability requirements, like for example, transportation or grid infrastructures. Also, these devices often use weak security authentication measures, which may facilitate unauthorized access to those devices. That can, for example, be a problem in smart home environments or also healthcare devices. And also communication is often unencrypted, which may lead to the problem that privacy sensitive data can be leaked. And that again can be, for example, a problem in healthcare. I'm working on a project together with Adrian called Cyan, which is a next generation internet architecture around which the work here is focused. Cyan is an approach that has security implemented by design, whereas most attacks in the Cyan network are essentially fundamentally impossible. A nice concept in Cyan is the so-called path-aware networking, where the sender knows the packet's path, unlike the current internet, where this is not always visible to the end user. And also a user can select the path, which enables, for example, to geofence its traffic. SIAN also provides highly available communication, for example, for critical infrastructures. And the nice feature of the path-aware networking is that multipath communication is possible. So I can choose paths that are, for example, delay sensitive, or paths that are providing high bandwidth. Actually, this is a very addictive feature of the SIAN network. SIAN is completely BGP free, and also in that respect provides better scalability than the current internet. It comes with improved network operation, for example, in that it is able to utilize the network resources better and provides advanced traffic engineering mechanisms. Now with SIAN, we would like to address some of the IoT security requirements. For example, the fact that end-to-end encryption and authentication is necessary. SIAN provides a mechanism called dynamically recreatable keys, which allows source authentication. Another feature is the hidden path feature based on EPIC. Every packet is controlled, which prevents exploitation of vulnerable devices with weak security measures. Also, with the multipath feature, multi-homed IoT devices can have guaranteed access. For example, this is useful in critical command and control environments. And similarly, with multipath, we can also complicate the analysis of the traffic, which helps to ensure privacy. And as mentioned before, also geofencing we can achieve by sending traffic over paths that that we trust. So with these mechanisms, we are currently in the process of implementing a use case around securing networks for IoT devices. Our deployment scenario is such that we have a monitoring site, for example, A here on the left-hand side, with an IoT administrator that would like to monitor sensor data from various IoT devices located in ISP Z here, E, F, and G. And with the SIAN mechanisms, it's possible to secure the network access such that only site A can access those devices. And in addition to that, also high availability can be ensured through the use of the carrier-grade SIAN IP gateway that is deployed at ISP Z, which enable a fast failover in case a certain connection fails down. All right, so that's in very brief how we like to approach the secure IoT problems. If you have any questions, I would be happy to answer them, or you can also email me later on. Thanks very much.
Thanks, David. I see that Marco has a question. How compatible is SIAN with the internet as we know it? Is it supposed to integrate, and if so, at what layer?
Right. So there is a feature called SIAN IP Gateway, which allows to essentially proxy IP traffic into the SIAN network. What we frequently use SIAN for is also as a kind of backup network, so that essentially in case the internet fails, then SIAN can be used as in a fast failover mode for sending traffic over the SIAN network. So for example, to connect branches of an enterprise, that is also a frequent use case. In addition to that, at the moment, we deploy SIAN over the internet as an overlay as well in many instances, whereas end hosts that are connected to the SIAN network don't need to be SIAN aware, because exactly that is being supported with the SIAN IP gateway.
He also asks, where does it fit with the non-IP efforts, for instance, the ETSI work?
Sorry, how does it fit with?
Non-IP efforts. For instance, ETSI work.
Maybe can you elaborate a little bit what type of efforts you're referring to here?
Marco, can you just unmute?
Yeah, sure, that might be easier. Yeah, no, I was referring to, for instance, Etsy recently spun up a working group to standardize a form of non-IP networking, and we've seen other examples, for instance, some of the push by Huawei to reinvent the internet, and I kind of wonder how Scion fits into all these standardization efforts that we see everywhere in trying to come up with something that resembles the internet but isn't necessarily running TCP/IP.
Right.
Marco, are you trolling?
No, it's a genuine question where I want to know where this is taken in terms of standardization, Randy. It's not
Right.
trolling. I really want to know where this is happening.
So there is a standardization effort ongoing at the IETF in the path-aware network working group. I'm not personally involved in that, so there are other SIAN folks that follow up on that currently, but it's definitely a valid question. So eventually standardization has to happen, of course.
Thanks, and good to hear it's in the IETF.
Thank you. Any more questions for David? In the meantime, since this is the last presentation, thank you for this, David. I also want to open the floor to questions about any of the presentations that you heard so far today, or any other remarks that you want to share. As I said, the session is for researchers, people from academia, NRENs. So if you want to share anything that you think is relevant, please go ahead and raise your hand. In the meantime, while you guys are thinking, I want to give the floor to Gordon because he still had a question for Nico from earlier today. Gordon?
Thank you very much. Can you hear me?
Yes.
Great. So thank you for the presentation, Nico. I had this one question. Did you deploy this solution you have created in P4 in production?
No. Unfortunately, there's a very simple answer to that. The NetFPGA environment that I used was unfortunately not stable. So the translator was running for a couple of hours. I think 4 to 6 hours was what I was achieving. After that, the NetFPGA itself would stop forwarding packets. So I assume this is part of the development kit that has a bug there. I mean, hardware-wise, it's hard to say. So it's not running in production, but if you're interested in looking at it, I can also share the source code. Actually be not too hard to port to any other switch, for instance.
Is it on GitHub or are you good?
It is on GitHub. I can share the URL, yeah.
All right, thank you. Any other questions? In the meantime, also a few of my colleagues wanted to share some relevant bits for researchers. Let me see. I'm going to give the floor first to Natalie. Natalie, do you hear me?
Yes, I do, and I'm here. We switch on. Okay, there I am. Hi, I'm Natalie. I'm Routing Security Program Manager at RIPE NCC. So I'm a colleague of Gergana. And for those of you who are doing research in the field of RPKI, BGP, these kinds of things, it might be interesting for you to know that we have 2 new data sets that we can make available for you if you're interested. I will put my email address below in a second. The first one can be found on ftp.ripe.net/RPKI. And what you find there is the data sets for all the ROAs that are out there. So you don't have to actually do RPKI origin validation to get to the data. So that information can be found on ftp.ripe.net under RPKI. Another data set that we make available only upon request, but might still be relevant if you want to do RPKI research, is we provide in collaboration with our legal team. So you have to sign an NDA, unfortunately, but I think, yeah, that's the way it is. You can have access log data from our publication point. So if you would like to use that, reach out and we'll happy to provide you. That was it for me for now.
All right, thank you very much. Sandra, you wanted to add something as well? Are you still with us?
Yes, I'm here. One moment. Hi, hello. Thank you, Gargana. Hi. So I just want to tell you very quickly, and especially for the people who are here from universities, that I work for the RIPE NCC in the Learning and Development team, and we do have a few remote courses, and we have the online academy where you can actually find resources online that are free, so you can just access our online courses for free. For example, if you want to learn about IPv6 or the RIPE database, we have some courses online now. And also recently we launched our new Certified Professionals program. So if you want to learn and get certified on what you've learned, we have currently only the RIPE database exam available. If you are LIRs, you got 3 free vouchers by email. If you're a student, I'm going to ask you, and you're not an LIR, I'm going to ask you to send us an email to exams@ripe.net if you would like to take the exam. And we can tell you that in the summer, we are going to launch the IPv6, the first IPv6 certification exam. So it was supposed to be a little bit sooner, but with the COVID-19, it got a little bit delayed, but we can guarantee now that it will be around the summertime. So if you have any questions, just you have Gergana's contact, so you can contact her and then she can forward it to us. Thank you. And let me know if you have any questions, of course, now.
Thanks. Thank you, Sandra. Thank you very much. All right, so last round. I don't see any questions in the chat. Let me quickly check also the participants panel. If there are any raised hands. Nope. So I want to thank you very much, guys, for joining. If you want to keep the links, please save the chat, just as a reminder. I will try to upload the recording for those who couldn't manage to make it in this particular time slot. Just finally, also want to give a last shout out to the RIPE Academic Cooperation Initiative. If you have, if you're doing original research, please make use of this opportunity to apply to get funding for flight and accommodation whenever we have our next in-person meeting. And please share this initiative with your colleagues. So yeah, this was it from me. Thank you very much again for joining, and I wish you a wonderful day. See you around at RIPE 80.
Thank you. Bye-bye.
Bye.
Bye-bye.